Hello everyone, welcome back to the channel. Today we're going to dive into the fascinating world of the central processing unit, or the CPU. This video will cover its components, how it works, and much more. By the end, you'll have a solid understanding of the CPU and its role in a computer. Let's get started. Our first goal is to understand the main parts of a computer. We'll understand how to draw a block diagram that includes the input, processor, output, and storage. We'll also explain the roles of RAM and ROM. We will be distinguishing between the main memory and permanent storage, and learn about the fetch execute cycle. Finally, we'll define hertz, megahertz, and gigahertz, and see how they relate to the processor speed. Before everything else, um, let's identify some key components inside a computer. This might be a good time to pause the video and have a think about what the following computer components are. Great. Now that you've done that, let's identify these computer components. So number one, that was the motherboard. This is the main circuit board that holds the CPU, the memory, and other essential components. The CPU, or central processing unit, is the brain of the computer. It performs calculations and executes instructions. Number three, that's the graphics card, or sometimes referred to as the GPU. This handles rendering images and videos. Number four was the hard disk drive. And number five, the solid state drive. They are both storage devices that hold your data. Number six is RAM, or random access memory, and is used for temporary data storage while the computer is running. Each of these components play a crucial role in the computer's operation. The motherboard connects all the parts, the CPU processes data, the GPU renders graphics, and the HDD, or the hard disk drive, and the SSD, also referred to as a solid state drive, store data. RAM provides quick access to data that the CPU needs. The motherboard is like the backbone of the computer, ensuring that all components can communicate effectively. The CPU, often referred to as the brain of the computer, performs all the calculations and tasks needed to run programs. The GPU is essential for tasks that require heavy graphics processing, such as gaming and video editing. HDDs and SSDs are used for long-term storage, with SSDs being faster and more reliable. These are the types of storage that you'll find more common in laptops and computers nowadays. RAM is crucial for multitasking, allowing the CPU to access data quickly and efficiently. So now that we've understood what some of these components are, let's see how these components communicate with each other. So this diagram is designed to kind of show you the data flow between different parts of the computer. The CPU communicates with RAM to fetch and store data quickly. It also interacts with storage devices like the hard disk drive and SSD to read and write data. Input devices send data to the CPU, which processes it and sends the results to output devices. The flow of data ensures that all parts of the computer work together seamlessly. The communication between components is facilitated by something called buses, which are pathways that transfer data between different parts of the computer. There are different types of buses, such as the data bus, the address bus, and control bus. Each serve different purposes. We're not going to go into too much detail with this, but I just felt that it might be quite important to just touch on this while we are talking about how components communicate in a computer. So the data bus transfers actual data. The address bus carries information about where the data should go. And the control bus manages the operations of the computer. So understanding how these buses work is crucial for grasping how data moves within a computer. But we're not going to go any further with this because this is designed for a Year 8 lesson. If you are interested in GCSE computer science, buses will be discussed in a lot more detail in that course. Let's move on to our next slide. So here's a simple diagram of the fetch, decode, and execute cycle. This cycle is fundamental to how a CPU processes instructions. During the fetch stage, the CPU retrieves an instruction from memory. In the decode stage, it interprets the instruction. Finally, in the execute stage, it performs the instruction. This cycle repeats continuously while the computer is running, allowing the CPU to process countless instructions per second. Let's break down each stage in a little bit more detail. In the fetch stage, the CPU uses the program counter to find the address of the next instruction. It then retrieves this instruction from memory or RAM and stores it in the instruction register. In the decode stage, the CPU's control unit interprets or translates the instruction and determines what actions are needed. Finally, in the execute stage, the CPU carries out the instruction, which could involve performing arithmetic operations, moving data, or interacting with other hardware components. This cycle is really fast, with modern CPUs capable of performing billions of cycles per second. So here again, I've provided a little bit more detail than we would for a Year 8 class, but again, this is worthwhile just mentioning since we're talking about the fetch execute cycle. Let's have a look at processor speeds. So processor speed is measured in hertz. 1 cycle per second equals 1 hertz. We also have kilohertz, megahertz, and gigahertz, representing thousands, millions, and billions of cycles per second. The speed of your computer's processor determines how quickly it can execute instructions. For example, a processor with a speed of 3 gigahertz can perform 3 billion cycles per second. This speed is crucial for tasks that require a lot of processing power, such as gaming, video editing, and running complex software. But processor speed is not the only factor that determines performance. The number of cores in a CPU also plays a significant role. Modern CPUs often have multiple cores, allowing them to perform multiple tasks simultaneously. This is also known as parallel processing and can significantly improve performance for multitasking and running demanding applications. The number of cores are usually sometimes referred to as dual core, quad core, or octa core. You may have come across these in your home computers. Additionally, technologies like hyperthreading can further enhance performance by allowing each core to handle multiple threads of execution. Let's have a look at RAM and ROM and what they do in a computer. RAM stands for random access memory, while ROM stands for read-only memory. RAM is a type of volatile memory, meaning it loses its data when the computer is turned off. It's used for temporary storage while the computer is running, allowing the CPU to access data quickly. It's kind of like the computer's workspace, just like you're sat at the table right now, where you might have your keyboard and your mouse, or when you're in an English lesson, for example, where you will need space on the table to have your books out, to be able to write on. It's kind of similar to that. ROM, on the other hand, is non volatile and it keeps its data even when the computer is switched off. It's used to store crucial data needed for the computer to boot up, such as the BIOS or firmware. When you turn on your computer, the CPU accesses the data stored in ROM to start the boot process. The data includes instructions for performing self-tests and loading the operating system into memory. Understanding the difference between RAM and ROM is essential for knowing how a computer starts up and runs. RAM is crucial for running applications smoothly, as it provides quick access to data that the CPU needs. ROM, on the other hand, ensures that the computer can start up correctly every time. When you switch on your computer, a small program in ROM, which is stored in ROM, called the Bootstrap Loader, runs automatically. This program performs self-tests to check that all hardware components are functioning correctly. These bits of hardware could be anything connected to the computer. It does also check to see that there is a mouse, a keyboard, a monitor, all connected to the computer. It then loads the operating system into memory, so into RAM, allowing the computer to start up and become ready to use. The Bootstrap Loader is essential for this boot process, ensuring that the computer can start up correctly every time. The self-tests performed by the Bootstrap Loader are known as the power-on self-test. These tests check the functionality of essential hardware components, such as the CPU, RAM, and storage devices. If any issues are detected, the computer may display error messages or beep codes to indicate the problem. Once the power-on self-test is complete, the Bootstrap Loader locates the operating system on the storage device and loads it into RAM. This process is crucial for ensuring that the computer is ready to use and that all hardware components are functioning correctly. Let's wrap up with some review questions then. What is memory? Memory refers to the components of a computer that store data. How does a hard disk differ from memory or main memory? A hard disk is a type of permanent storage, while memory or RAM is used for temporary storage while the computer is running. What is a processor? The processor, or CPU, is the brain of the computer. It performs calculations and it executes instructions. Understanding these concepts is crucial for anyone interested in how computers work. Memory is essential for storing data and running applications, while the processor performs the calculations and tasks needed to execute programs. The hard disk provides long-term storage for your data, making sure that it remains safe even when the computer is turned off. By understanding these components and how they work together, you can gain a deeper appreciation for the complexity and power of modern computers. So that's it for today's lesson, guys. Thanks for watching, and I hope you found this video helpful. Don't forget to like, subscribe, and hit the bell icon for more tech content. If you have any questions or topics you'd like me to cover in future videos, leave a comment in the comment section below. And that's it from me. And I'll see you next time. Bye for now.